welcome guys. So in this video, let's talk about interesting idea to solving the quartic equation. Okay, so one idea, so quartic equation in general is hard to solve, right? But there is a special type. So there's a special type which is easily to solve. Looks like this. Okay, so this is a special type of the. This is a special type of quartic equation. So instead of the general a b c d, right? We change this to be the same as this. Okay, so general idea to solve this is just divide the x squared. Okay, and that you can let x plus 1 over x to be t. So you can combine these two, and these two, and this one. So you get let's say if you square it, you get x squared plus 1 over x squared plus 2. So you get t squared. Oh, by the way, yeah. So this d needs to be 1. Okay. So you get t squared minus 2 plus a t plus b. So you can solve it by quadratic. And you solve it by quadratic, you get t, and then you can solve x by quadratic. Okay, so this is the idea that if your coefficient are basically symmetric. So you see these are both 1, these are both a, these are both b. Okay. Yeah, so this idea can so you can solve you can first solve this by quadratic solving t and go to solve x. Okay, so let's see an idea. Let's see an example. This example is also interesting. So in order to solve this x to the 5 equals to 1, right? So if you know the answer, it can be written as exponential 2 pi I n divided by 5, right? N should be 0, 1, 2, 3, 4, right? So you can written as cosine 2 pi n divided by 5 plus I sine 2 pi n divided by 5, right? So yeah, I mean this is fine, right? This is fine, but I want to, as you know that I want to solve cosine and 2 pi n divided by 5 and sine 2 pi n divided by 5 into rationals. So into rationals means that I want to use plus, minus, times or divider and the square root. Okay, so this is actually this is related to the famous theory called Galois theory, and I plan to do in the future in my YouTube channel. Yeah, so basically the Galois theory will tell you that what is the proper prime number which can put here, then you can directly solve. So actually one can solve this cosine 2 pi n divided by 5 and sine 2 pi n divided by 5 into the expression of plus, minus, times, divide, and square root. Okay, so let's do it. Yeah, so this is easy to solve once we have the technique. So we can write as this. So this is x equals 1, and we need to solve this. Okay, so in order to solve it, let's take t equals to x plus 1 over x. So this equation can be written as divide x squared. You get x squared plus x plus 1 over 1. Oh. Plus 1 over x plus 1 over x squared, 0. So you get t squared minus 2 plus t plus 1. So you get t squared plus t equals to minus 1 is 0. So from here that you get t is minus 1 plus or minus square root of 5 divided by 2. Okay, so you get the x plus 1 over x equals to minus 1 plus or equals square root of 5 divided by 2. Let's call it t, right? Because we need to, I want to solve it generally. So one can get this equation like this. Plus 1 and then minus tx. So x squared minus tx plus 1 equals 0. And easy to solve x, right? X is a t plus or minus square root of t squared minus 4 divided by 2. Okay, so from here that we get our general answer. So our general answer will be x equals to half right. This is our answer. Yeah. So so if you choose plus sign here, then you need to consistent, right? So there are total 4 answers. Okay, and this part is imaginary. Okay, so one can easily show this. Let's say, so your cosine 2 pi n divided by 5, right? The first one is n equals to 1 will be cosine let's see 72 degree. Okay, so if you can solve by geometry by solve this diagonal line of the pentagon, right? But the easy to prove that the cosine 72 degree will be from here is plus minus this minus 1 plus square root of 5 divided by 4, right? Because you know it's positive, so you can easily get this. Okay, also this is famous result by cosine 18. Okay, so this is the I have a previous video that use pure geometrical way to solve this sine 18 and the cosine 72. Okay, but in this video we can solve it pure algebraically. So you see, amazingly, that cosine 72 and the sine 18 or other like cosine 140 can be written as the square root of basically the number that you are familiar with, right? And this is due to the famous Galois theory, right? So if you try to solve cosine 2 pi divided by 7, then there's no easy way to solve it. To write cosine 2 pi divided by 7 into some square roots, right? But you can solve this by but cosine 2 pi divided by 17 can be written as a plus or minus the square roots, and this is done by Gauss, right? And also basically it's the famous results of the Galois theory. Okay, so in the future I will build my my own Galois theory list and prove everything, and give the detail. Okay, so see you guys next videos.